There are like 9 billion programming languages on Earth, and not a single one is good. Still, to this day, that's insane. We have like a little Lua table in here. Don't want to get the length of it, and don't want to iterate over it. Right, so it works as expected. The length is 5, it only counts the array part, and, brings the key and the value. That's expected, but they don't want to represent like the absence of something as an element of the array. Back in the 60s and the 70s, we used to do -1, because there was no better way, right? You just expect that -1 should not exist in this environment, in this context. But then we came up with nil to represent the absence of something. But Lua treats nil very liberally, so the array part gets cut out at 3. For some reason, I don't know why. Well, I actually do know why. And when we iterate over it, it skips over 4, right? And that's actually it. This part, this used to be like in the array part, now it's in the hash part, which makes it slower and makes it way like less predictable. So yeah, 1, 2, 3, and then it stops. This is the hash. This is the same kind of like thing as this is, which is insane. Right, that's not something that you would expect. Like by inserting something, you shouldn't delete something. But yeah, my language kind of solves it. Like Loki solves it. So we make a little table is the same thing, but now it looks like this because null does not exist at all. Neither does true or false or I don't know, null, undef, and neither does this. They're all atoms, and atoms are like their value equals to themselves, and that's it. And you can actually make them free with some optimizations, which I'm gonna talk about later. But if we print the length of t, it's gonna be, as expected. Well, length of t. Let's do it like that. We can also print tables, unlike Lua, by the way. But yeah, it's 7 because we count the keyed part as well. And then we want to iterate for value in t. We print the value, and let's wrap it in a little do end block. We don't actually have to wrap it in, you know what I'm talking about. Yeah, it's just like that. Let's do for t in t keys, and then we do like a little string interpolation, so v, and let's make it pretty, right? And it's gonna be t at v, and then that's gonna be pretty, right? I don't know, that just makes a lot more sense to me. So yeah, that's how we do it. And actually, if you take a look at this, the reason iPass fails here is that you cannot return nil from an iterator. That does not exist because nil means the iterator stopped, it ended, and there's no way to like do it differently. Otherwise, you would have to use like true or false or some string. That would be very weird, and that's not gonna be something that you wanna do. Well, here we do it differently. Since all atoms are free, whatever they are, we can use done instead of nil. Wow. Yeah, so that's like the iterates work the exact same way except you return done. And as a matter of fact, like you can do this. We can check if t's element number 4 is equal to t's element number 420 or something. It's gonna come up true because they're both nil. That's not something you want to do because you want to store nil in your arrays actually. Like that's expected. So yeah, you can do t at 3 is t at 420. Well, t is lowercase. We actually have an LSP, by the way. And it's going to be false. You know why? Because we can use one more atom here for undefined. So t3 is going to be just nil, but t at 420, that's going to be undef. Wow, isn't that beautiful? Isn't that just amazing? And you can actually put undef in an array, but that's not going to behave the way you want it to, right? You're going to check if an element is present, and that's like you're going to check if an element is present by comparing it to undef. Which is bad because your element is going to be present, but it's also going to be undef. But you're going to have to deal with that low-key because I don't want to crash the program on a key not existing. That's not something that I want to do. So yeah, that's how it is. And actually, one more thing, that's how we do falsiness. So we have like a little table called core atoms right here. It's an enum. It has all of the atoms that should be predefined that are known at compile time. So we know their IDs, like we know what they look like as like the representation of data in the NAND box. So we know that nil is always going to be equal to like 0x that be whatever, because we make sure that is true when we make the VM. Same for all of these. But the reason all of the false atoms are at the beginning is because we want to have like a falsiness check, just like this. So something is false if it's a number and it's 0, or if it's an atom and it's between nil and false. And that's how you do it. Well, false is like last false. But it essentially means false. Yeah, and then you compare it by number. As a matter of fact, I'm seeing something like really weird. Like there's an optimization here. So all the data are actually a U64, right? Because they're like an AND box. So you can compare them as numbers. So you don't actually need two branches here. So you can return if value is data.new.num of 0, and that's going to return us like a number of U64 that is the only way you can represent a number of 0, or value is over or equals data.new.atom. Do we have data.new.ca? No. Did I remove it? Well, that's weird, but 0, right? Or value, wait, no, not or, we need an and here. And value is less or equals data.new.atom, core atoms.last false. Right, and that's it. You don't actually have to do branches. I feel like this is not allowed for type memory.data. What are you talking about? It is. It is. Oh, value.bits is equal to this, which doesn't cost anything, so it's fine. Bits. I'm probably gonna do some benchmarks to figure out where like the compiler optimized all of that for me, anyways. Probably didn't actually. Probably I don't think it's gonna be able to figure that out. But yeah, let me just revert it and then do some benchmarks. So yeah, thanks for tuning in. I hope you enjoy. I hope this wasn't like too fast to spread it because I get kind of lost in my words. But yeah, check it out.